Hello, welcome. My name's Bill Moore. I am the Chief Solutions Architect for Atmosoft. And today I wanted to talk about object-oriented programming concepts. I was having an interesting discussion this morning on LinkedIn and thought it would be a nice review to kind of go over some of those concepts. So first of all, what is OOP? It stands for Object-Oriented Programming. It's kind of the main methodology. Although you kind of have two flavors. You have languages that are built from the ground up using OOP, like .NET, and you have languages like Python, JavaScript that have OO features in them, and you can do object-oriented programming, but the core part of the language is not necessarily object-oriented. And what that kind of particularly means is, for example, there's not really a concept of a private member in JavaScript, at least in the current iteration. Although if you're working with TypeScript, I think that language is more OO friendly, even though the output is actually JavaScript that is not object oriented, but it allows you to kind of use some of those more advanced object oriented features. So let's dive in and just kind of talk about what the main features of object oriented programming are. First one that always comes up is encapsulation. Encapsulation is the concept of have an object, and the object has both an external and an internal state. So one of the things that we like to that we use encapsulation for is for um, um, it's so you the object can do the work it needs to do to serve its function, but this is stuff that doesn't need to be exposed outside of the object itself. And so this is done with accessibility and gives you the ability to hide methods and parameters and or sorry methods and properties inside of an object. For example, that was not the best explanation of encapsulation, but an example would be on encapsulation is I have a class, and that class has private, or sorry, not private, it has public members available to it. So when I create a car, maybe it has a run method. Okay, and so that run method is exposed publicly. So when I instantiate a new object, and for those of you who are unaware, instantiation is basically creating an instance of an object. So when I use the new keyword in .NET, I'm instantiating a new instance of that object. And there could be a method on that object called run. So we're talking about a class that's modeled after a car, and we'll talk about abstraction next. So we have a class, it's a car class, it has a run method. So I can create a new instance of the car by saying new car, and then I could say car.run, and then whatever that run method does, that work gets done. Now, what happens internally to the run method, we don't really care about and we don't need to know. That run method could call 20 private methods inside the class that are doing different versions of work or doing different types of calculations. We don't, from external to the class, we don't care what's going on in the run method. We just want to use the run method to perform a task or to do some work, and then receive the output of that method. So that's kind of the concept of encapsulation, is the ability to hide basically call private information inside of the object. So things that external to the object itself and how the object manages its own state are don't need to be exposed to the external world, because we don't want people manipulating those. And so that's kind of the concept of encapsulation. The number two is abstraction. So abstraction is kind of the concept of so let's see what it says. It says, I want to make sure I get this right. The concepts are solid. I just want to make sure I don't misrepresent. So in OOP, classes act as blueprints for creating objects, and abstractions allows you to define these classes at a high level, focusing on what they do rather than how they do it. The separation of concern makes the code easier to manage and understand. So an abstraction would be kind of like a real world kind of implementation of like an automobile. So you have an automobile class, and you've got all the, you got the run method, you got the, the check engine light method, um, and you're basically kind of modeling, you're abstracting a real world object down into something that's easier to consume in the code. Next major feature is inheritance. So inheritance is kind of one of the critical OO concepts, and you'll see it a lot when you're deriving from an interface, or you're using another object you're basically stacking functionality on top. So if I have a class called animal, and the animal has a property called we'll call it like life points. So the animal has life points, right? Every animal in the application, anytime you use the animal, they get to have this property which represents the number of life points that they have. Assume we're working on a game, right? And when I want to create a specific type of animal, I could create a tiger that inherits from animal, and then tiger gets the property life points, right? So now I have a base class called animal, and then I have a class that inherits from animal called tiger. So I can create an instance of an animal, and I can create an instance of a tiger, and you can get way more complicated with this. So let's just say the tiger has a roar method, right? And so you can create an instance of a tiger, and you can have it roar, and it prints roar out on the screen, right? But if you create an instance of an animal, it does not have the roar method because that wasn't defined for that particular class. But the tiger has the roar method and the life points. And so it's a way for you to kind of structure your code and build functionality on top. Where this gets super interesting, and one of my favorite things to do with this is you have a base class, and I have varying different types. So let's just say I have a base of I'm using automotive examples because it's one of the industries I'm familiar with, and some of the stuff I'm currently working on, so it's kind of top of mind. So when I have a warranty, I could have a warranty base class that has all of the standard information associated with every warranty. Okay. And I have standard methods that are associated with every warranty. Then I create a derived class, or a class that inherits from warranty, to add specific properties and methods to. Where it gets really cool is I could have a list that has all of these different types of objects in it, and that list is just representative of the base class. So I could treat every one of the objects like it's the warranty base class. And then there are tricks you can do with casting and different things if you need to call specific methods on specific derived objects. But it gives you the ability to. I have 500 different warranty types with different properties and different methods and that kind of thing, but I can store them all in the same list because they all derive from the same class, and I can work on all of those classes at the base level. Like you could have in your base class an implementation of calculate amount that figures out the total cost of the warranty. Okay. And so, and then that calculated amount can be overridden in your inherited class. And then you can put in specific logic on how that particular warranty type is supposed to calculate it. And then because I inherited that method from the base class, I can then just cast everything to the base class and call their calculate amount method, and then let them all do their work. But programmatically, I can kind of treat them all as the same because they're derived. So that's kind of the concept of inheritance. That one is, I wouldn't say it's the most important because they're all important, but that one's kind of critical to understand is the idea of taking these objects and kind of layering on top of them, and then the fact that even though I have maybe this, base class has, 500 slightly different implementations for the different types of warranties that I'm working with, because they all inherit from this base. I can work with this base object and just treat all of the different types of warranties as the same, right? And we'll go, if people are interested, we'll go into more we'll go into some more concepts around that. So the next one that we want to talk about, this one always confuses me. So I'm going to read it, and then we'll talk about it. So it says polymorphism allows objects of different classes to be treated as a common superclass. So actually, we just talked about it. So what I was talking about was kind of the polymorphism concept, which is related to inheritance, right? So I kind of went down, and so again, we'll just kind of restructure what that means. Is I have a warranty base class, and then I created all these they're not super classes. I created all these subclasses that are based on that warranty base class, and then I can act on these new derived classes like they are. I can act on them like they're the base class, and so that kind of normalizes the code. And there's some neat things you can do with, like, you can in .NET you can declare a function as virtual or abstract, which means in the base class I'm not going to create. Or it doesn't mean this. They're two different things. But if I have a an abstract method in an abstract class, and then I inherit that, I can create everything like it's the abstract class, and then I can call those methods, which have to be implemented in the derived class. I can call methods on it, and even though they're actually different objects, because they have the same inheritance structure, and because everyone has to implement this interface. So let's just say you have in the warranty, going back to the warranty example of talking about the calculated amount. Say you have an abstract method in your base class with no implementation for calculate amount, right? And I have 10 different types of warranties that are getting put into the same list. I can cast all of those to the base class, which is the warranty base class, and I can call the calculate amount, and that work will happen for each one of those derived types. So instead of having to treat them all as the individual types that they are, I can treat them as the base class, and then that's super powerful in just both logical representation and programmatic work that you're doing. The ability to be able to say, okay, for example, in .NET, you have the concept of object. Okay, so the object is the base class that everything in .NET derives from. There's one class called object. It has, what is it? Has two string, and there's one other override there, where but everything is of an object. So at the worst case scenario in .NET, you can always just cast everything to an object, which wouldn't be super useful, and haven't had to do that a ton of times. But and then you can work with everything like they're the same, because they're all from that same base class. And so polymorphism is kind of it's basically saying there are two types of polymorphism in OOP: compile time method overloading and runtime method overloading. Occurs when multiple methods with the same name but different parameters exist within the same class. Okay, so that's kind of another concept along polymorphism, where I could have let's see. Oh, I could have a calculate amount method, or I could have a calculate or define products method that goes ahead and takes different parameters because it does different actions. So maybe in one case I'm passing in a list, or a list of decimals. Another case I'm passing in maybe we want to work with whole numbers, so we're passing in a list of integers. And then those two methods are the same depending on what method you call and pass in. You can take different actions based on the parameters specified to the method. That was kind of the piece I was missing. So it's not really related to inheritance. But polymorphism is kind of one of those ones. It's a little confusing, not like super confusing, but it basically allows you to have the same method, and it doesn't have to do the same thing depending on what parameters you type. So you can write the calling code and say, say, it doesn't matter if the work you were doing before in the method was working with decimals, it's going to call this one method, and then another case you're going to pass in the list and it's got integers, and you can call into that. So that's kind of an overview of OOP. I think I kind of tanked on on the polymorphism. A couple of these I get. I understand the concepts, but I get them a little bit confused. Um, uh, so and that's kind of like I had to say, like, the most important one in my mind is probably the inheritance. The abstraction one is pretty good, and encapsulation is super important too. I really like the fact that I can, let's just say you're working with a group of developers and everyone's not always in the same at the same skill level, right? And so I can implement a class that says that is handling a super complex concept. Like, let's just say we're doing something with authorization. That one's always kind of challenging. And so this authorization um, class can in you can encapsulate and hide all of the complexities of the encapsulation. You could suppose two methods: log in, take some parameters; log out, take some parameters. And then you just hide all of the internal details on how you actually do that. And then the developer needs to add authentication to their application. Oh, I'm just going to create an instance of this service. I'm going to plug it into the middleware pipeline, ASP.NET Core. It's going to sit here. We're going to call the login and we're going to call the log out method. And all the internals of that are hidden. Like, the developer doesn't need to know or understand the work that you had to do to get that to work. It's very simple. So I like using encapsulation to make complicated code a lot easier for other people to consume. And you can do that around APIs, right? You can use this encapsulation principle definitely around APIs, where maybe an API management layer would be something that you could consider kind of encapsulation, right? If we have a bunch of microservices running on the back end, and we know that the user just wants to get the orders. So we have a customer and they have orders, and we just want to get a list of orders. We don't we can encapsulate and we can hide the implementation details of the microservices by exposing it through that API management layer. And then you're going to go out and you're going to get the you're going to get the you're going to get the customer, you're going to get the order, you're going to combine that into, a result set that you're going to return, and then you just return that result set. And then the consumer of the API doesn't need to know, oh, you need to call get customer first, and then you got to get back that ID, and then you got to call the orders endpoint, and you got to pass in the ID, and then we're going to send you back that information. They don't necessarily need to know that they need to consume that. So all right, everybody. I hope everybody has a great day. I'm going to call it out for today. And hopefully I'll see you guys all. We'll be back tomorrow. And I hope you have a great day and write out some good code. Bye, everybody.